we're going to create a fourth degree polynomial that approximates that function, f of x equals e to the x over 2 around x equals 0. So let's just go ahead and start writing what that polynomial function would be, okay? Fourth degree polynomial function, I'm going to call it p sub 4 of x equals, okay, well, a fourth degree polynomial is x to the fourth, x to the third, x to the second, x to the first, and x to the 0. I'm going to do those backwards though. So x to the 0, oh, there must be a coefficient with it. I don't know what it is. I'm going to call it a sub 0. Obviously, you can leave off that x to the 0. And then a sub 1, x to the 1, a sub 2, x to the 2, a sub 3, x to the 3, a sub 4, x to the 4. Okay, there we go. We have this polynomial that is a fourth degree polynomial, and I'm going to erase some of the unnecessaries. Sometimes in the course of this lesson, I will throw in some unnecessary understood things just because there's a pattern to it, and it's really good to help us notice that pattern. So I'm going to erase that, I'm going to erase that, and there we go. So here's the deal. Our fourth degree polynomial, as you just saw on the computer, our fourth degree polynomial had better have the same the same y value at 0 as our function. It also better have the same value of the first derivative at 0, and the value of the same second derivative at 0, and the value of the same third derivative at 0, and the value of the same fourth derivative at 0, and you can go on as long as you want, but they said fourth degree, so that's what we're going to do. So here we go. P sub 4 prime. I need to find some derivatives. We're going to take the derivative of this nasty thing. When I do that, that term goes away. I'm left with a1, 2a2x plus 3a3x squared plus 4a sub 4x cubed. We're going to do this till we get to the fourth derivative. This will come in really handy in just a minute. I don't know why I put an F there. That should be a P. So p double prime sub 4 equals, all right, that term goes away. 2a2 6a3x plus 12a sub 4x squared. Okay, take the derivative again. P triple prime sub 4. That again is fourth degree polynomial. That's why we have the 4 there. This term goes away, and we have 6a sub 3, no x, sorry, about to put an x there, plus 12, whoops, 24, a sub 4 x, and then the fourth derivative is 24 a sub 4. Okay, why did I do that? Because I need to. That's going to come in handy in just a minute as we begin to approximate some things. So now let's take our actual function, and we'll put our function here. So f of x equals e to the x over 2. And I'm going to find the value, I'm going to find the derivative of that, which would be 1/2 e to the x over 2. And this blue marker is dying, so what we're going to do is grab another one. So we have f double prime, much better, is equal to 1/4 e to the x over 2. F triple prime is equal to 1/8 e to the x over 2. And f quadruple prime, I should have used the 4 there, but I didn't, equals 1/16 e to the x over 2. Okay, so here's where this is going. I need this to equal this at x equals 0. Okay? Well, let's do this the easy way. I want to find out what f of 0 is. F of 0 is 1. Plug in 0, you get a 1. Okay? I want to find out what f prime of 0 is. That would be 1/2. I want to find out what f double prime of 0 is. That would be 1/4. I want to find out what f triple prime of 0 is. That would be 1/8. And that would be 1/16. So here again is where we're going with this. We need this polynomial up here in all its glory to equal these values at those derivatives. Whoops, I need a 0 right here, not an x. let's think about this. If I plugged in a 0 right here, and I'm going to do it, and you may not have room in your paper, but I'm going to kind of squeeze it in. P sub 4 of 0 had better equal 1. Okay, well, that means a sub 0 is something I don't know, and I have a1 times 0. You really don't have to write this because it's going to become obvious where this is going in a minute, so I'm not going to do it on the other ones. And then a sub 2 of 0 squared, and then a sub, you see it, right? 0 cubed, and then a sub 4, excuse me, of 0 to the 4th, and that had better equal 1 because of that right there. And so we go through all that mess, and basically we know now that a sub 0 equals 1. All right? Cool. Fantastic. Let's do the same thing here, but let's cut out some of the work. So P prime of 0, I was about to put a 4, let's put the 4 down here. P prime of 0 equals, all right, if I plug the 0 in, here, they're all gone. So A1 equals 1/2. Well, cool. P double prime of 0 is, well, gone. So 2A2 equals 1/4. Oh, okay, what that tells me is that a sub 2 is 1/8. Okay, let's keep going. P triple prime, this is going to be gone, and I have 6 a sub 3 equals to 1/8, and that means that a sub 3 equals 1/48. And for this last one, P 4 of 0 is 24 a sub 4, and that is equal to 1/16, and that means that a sub 4 is something that I should know off the top of my head, and I don't. Whatever 16 times 24 is in the denominator, 1/384. Okay? Fantastic. Fantastic. We have found it. We found it. Now, we're going to write it out in all its glory. And now we have a polynomial that actually you saw on the computer a few minutes ago, and it will approximate it. And I'm going to put my final answer down here in this bottom corner, and that's going to lead us to an understanding of the structure of the formula. So, my 4th degree Taylor polynomial, in this case it's also a Maclaurin polynomial. We'll discuss the differences there in a minute. Very subtle differences, easy to understand, is going to be all this stuff, but now I know what the numbers are. So a sub 0 plus a sub 1 x, oops, and then a sub 2, which is 1/8 x squared, and then 1/48 a cubed, and then 1/384 x to the 4th, x to the 3rd, not a to the 3rd. I think I said a instead of x. That down there is my final answer. Okay, let's start making some sense of some things here. This is my answer, but it's going to lead us to the general form of a Taylor polynomial and a Maclaurin polynomial. So I'm going to erase a lot of extraneous stuff, and we're going to extract some structure from this. And I'm going to write it over here with the good marker. Okay. Well, the good marker. A Taylor polynomial. What's that? Taylor polynomial is centered at x equals c, and it has this form right here. So P sub n. I'm going to have an nth degree Taylor polynomial. It is going to say, well, I start with a sub 1. Well, what is a sub 1? Well, a1 is the value of my function at c. I'm going to add a couple extra things to that in a minute. And then, and I'm leaving a little space here for some extra stuff that you don't have to write. And then it's the value of my derivative at c. And then it's the value of my second derivative at c. Oops, I need an x here. I'm forgetting some stuff. Here we go. But if it's going to be centered at c, then I need to do this. And then I'm going to have second derivative at c, x minus c squared. Now, don't you stop the video here and say, oh, we're done. No, we're not. I need to do some major fixing on this. And then we will keep going with f triple prime at c times x minus c cubed. And this goes on forever until you get sick of it. And it's f nth derivative at c times x minus c to the nth power. I have left some very important stuff off, and we're going to fix that right now. Okay, I want you to notice a pattern here, and here it is. 1, 1, 2, 6, 24. I hope that sequence looks familiar to you. I would like to think it does. I'll give you a hint. The next one's 120, and after that is 720. These numbers get really big really fast. This is 0 factorial. This is 1 factorial. This is 2 factorial. This is 3 factorial. This is 4 factorial, 5 factorial, and 6 factorial. And they keep going, obviously. Okay, in the process of determining what my coefficients were, I had to divide by 1, which didn't matter, divide by 1, divide by 2. Okay, I divided by 1, which was 0 factorial. You can put that there or leave it off. You're dividing by 1. I had to divide by 1 factorial. I had to divide by 2 factorial. I had to, divide by 3, it chokes me up, factorial. In this case, I would go all the way to n factorial. And that is the general formula for a Taylor polynomial that's centered at c. And again, let's notice that it's centered at c because you have that shift right there. And here's one more thing that I'm going to throw in just because there's a pattern to it. X minus c to the 0. You could put that, or you could totally leave it off. Okay, let's write one more thing. A Maclaurin polynomial is centered at x equals 0, and it has this form. It's the same thing, only instead of c's, we're going to have zeros, which simplifies things quite a bit. So whatever degree it is, the nth degree is f of 0 over 0 factorial times x minus 0 to the 0. Extra stuff, don't feel like writing. And then f prime of 0 over 1 times x to the 1 minus 0, x minus 0 to the 1. And then f double prime of 0 over 2. You could put it over 2. I'm going to put it over 2 factorial. And again, that's over 1 factorial. And if you really care, that's over 0 factorial. And this is x squared. And we can continue with this. Third derivative at 0, 3 factorial, x cubed, plus dot, dot, dot. We get all the way over here to the nth derivative of 0 over n factorial times, don't need a parenthesis there, x to the n.